Welcome to today's webinar around building a solid API testing strategy to enable continuous testing. My name is Mark Lambert. I'm the Vice President of Products here at Parasoft, and I'm joined by Chris Colosso, Product Manager for our functional testing products. Chris, you want to say hi?
Hey, everybody.
So with that being said, let's go ahead and get started. Before we actually jump into talking about API testing strategies and how to correctly do them so you can enable continuous testing, we'd like to run a couple of quick polls to get a feeling for the audience who's there. So let's go ahead and run our first poll. Okay. There we go. Fantastic. Thank you. So what is your current level of API testing? Are you just starting out? Are you thinking about doing it, trying to identify the appropriate business cases or applications? Have you started or identified those use cases and now trying to choose the right tool? Are you doing API testing to some level today and figuring out how to scale across the teams? Or do you already have an established API testing practice and you're looking for ways to improve and kind of increase the adoption of API testing across the organization? And quickly, just click on a couple of boxes there. Or select one of those. We'll just give a few moments for a couple more people to enter. Chris, do you want to talk to this at all about how you see customers and clients that you talk to about API testing?
Absolutely. Thanks, Mark. It's kind of interesting because as we're so deeply connected to API testing, there's this assumption out there that everybody is just doing API testing broadly across their organization. And I always find these types of polls really interesting. Because it lets us identify where the real world is. Okay, so it looks like we've closed down the poll. Let's go ahead and look at the results. That's interesting. So it looks like it's pretty equally spread out across there. Many organizations are just sort of getting out there. They're in the ideation phase around API testing. They want to kind of get started with it. Looks like we have a slight increase towards the bottom. People are doing API testing.
Yeah, so, to be honest, it's actually about 25% across the board. So that's great. We've got a great mix of people. So I think today's session is actually nicely aligned. Now, when it comes to API testing, though, there are different types of APIs that you're trying to test against. Can we run the second poll now? And on the second one, just click on the elements that you are testing in your system. So, we would be expecting that the majority of people are doing REST-based services. That for sure is the most common in the industry. But then API testing really expands beyond just a REST, JSON, or XML-based service. It also encapsulates enterprise services typically implemented with SOAP, maybe over JMS or MQ. We see a lot of people looking at microservices and some of the special protocols that are associated with microservices. Obviously, a lot of people do microservices just as HTTP REST endpoints. We also see mainframes, organizations trying to figure out how to test a Salesforce application. For those of you who don't know, there are some APIs in there which you can use to start doing functional validation of Salesforce workflows, and then SAP as well. Chris, did you want to touch upon any of these real quick while we run?
No, I'm particularly curious about this one. I mean, the term API is so overloaded these days, and it's interesting what technologies are at play. So I'm particularly curious what we have here.
All right.
So looks like
almost 90% is REST, which is what that's good. That's what I would expect. Actually, this is pretty good because it does actually map to the order that we thought it would be. The other one's really interesting. So if you're testing other types of services, if you could just throw a question or a chat comment into the Zoom session, that would be great. Maybe we can kind of pick up that and talk about that as we move forward today. But thank you very much for that. That's really helpful. It helps us understand the audience a little bit better. And the good news, I think, we're nicely aligned. So before we jump into the specifics of API testing, you've got to think about what the purpose of API testing is. And it fits into a larger strategy as you're trying to automate your testing practice and really enable this term called continuous testing that we're really going to talk about and dig into today. At Parasoft, we believe strongly in the testing pyramid, which probably many of you have already heard of. This is very much proponent, very much kind of the founding fathers of Agile kind of really look towards this. Martin Fowler, Michael Cohen, also two very strong proponents of this strategy. What it does is it says, hey, we should have a broad set of unit tests, providing us a solid foundation to our testing strategy. Unit tests can be run quicker, they can be diagnosed easier, they run typically in isolation. And then you start backing them up with broad business coverage at the API level using API tests. It is a pyramid, not a trapezoid though, so you still have UI level end-to-end workflows that you want to be validating. But what you want to do is you want to focus the automation of those UI workflows to identify the critical business workflows and really free up your manual testing effort to do exploratory or negative testing, boundary condition type testing, rather than kind of do functional regression validation. So the bottom line is, by building a testing strategy or portfolio of tests that has more unit tests than API tests and more API tests than automated UI tests, it gives you a very easy to scale testing process that really can provide you valuable feedback as part of your continuous strategies. However, when we actually talk to clients and talk to people about how they're doing testing, most folks will identify with the inverted pyramid or the ice cream cone. This is not, if this is how you currently view yourselves, don't feel bad. This is still the industry norm, unfortunately. And it's pretty easy to understand why. UI-centric tests, because the UIs are designed to be intuitive, and typically most business flows or business use cases align to the UI. The UI is easier to define, but it is much harder to maintain automation at this level. And obviously, manual testing, trying to take your all of your different kind of intuitive testing practices that are the manual testing level and trying to map those into an automated process is very tricky. And then conversely, on the bottom, while the unit tests and API tests are quicker to execute, it's a much simpler test environment, they do require more technical expertise to be able to create and maintain those tests. So the bottom line is organizations are struggling, and they're struggling actually worse than most people realize. API testing often is skipped by many organizations. So I'm not surprised to see that we still have a very large audience at these very early stages. So investigating, trying to find the use cases, or really just trying to find tooling represents about the 50% of the audience today. This is not an uncommon situation because API testing suffers from some challenges around adoption. We'll talk about those today. We'll talk about how you can mitigate those. But often what we see is more of the martini glass rather than the ice cream cone, where in essence you skip right past the API test because they're in this no man's land, and task development with doing some unit testing. Now, obviously today we're talking about the Parasoft technologies. We will be focusing on the general strategy and approach, but so you kind of understand where the technologies fit that we'll be talking about today and using as our examples. Firstly, let's start talking about the bottom of the pyramid, creating that foundation of unit tests. This is where Parasoft's JTest product fits in, helping organizations to create vendor-neutral JUnit test cases, guiding the developer through the process of how to create a meaningful and maintainable unit test. In essence, growing that stem of the margarita glass or the martini glass out. JTest also is focused on helping uncover deep reliability and security issues within your application code base through deep code analysis, going beyond what you would have with a SonarQube or open source analyzers, helping you achieve compliance within regulatory industries, as well as standards such as PCI, where you need to have OWASP or CWE coverage. So that's how we would help at the lower levels of the pyramid, but really where we're going to focus today is around how we can help teams accelerate the adoption of API testing, how we can help you get going, not only from the point of view of building a test manually, kind of what we think of as creating an API test by design or bottom up, but also how we can help you understand how an API is used and take real world use cases to kind of create tests that demonstrate how an API is consumed, and kind of more of a top-down approach leveraging the UI-centric model. Now, our goal here is to create those API tests that can be re-leveraged for load and performance testing, but also giving us interesting attack vectors for security penetration tests. We're not going to go into those in detail today, but the shift-left performance testing will be actually part of a future webinar that we'll be doing later this year. Now, when it comes to shift-left performance testing, and one of the key elements to unlock continuous testing in your environment, you need this concept called service virtualization. Service virtualization helps me eliminate external dependencies and simulate the behavior of a back-end system. By doing that, I can unblock my agile development streams. I can ensure that I have a scalable test environment that allows me to do early stage shift left performance performance testing with performance characteristics, but it also helps me test the different scenarios that maybe my live system doesn't have the ability to do. So different corner cases of test data, etc. And we'll talk about service virtualization at the end of today's session. We have 3 case studies. Hopefully we have time to go through all of those today, but we'll be making the slides available after the session as well. So they'll be available for you guys too. So the bottom line is, by aligning to the testing pyramid, we have this scalable test automation strategy. But if you don't have visibility as to what's going on across these testing practices, it kind of doesn't give you the feedback that you need. And this is where Parasoft provides a centralized view of quality with Parasoft DTP, our reporting and analytics platform. This will aggregate data from all of the different testing practices, and also gives you the ability to correlate code coverage with functional tests. This was actually one of the questions that was asked coming into the webinar, actually a couple of different questions around coverage. You can track code coverage of the backend APIs and aggregate that with your functional test data through the use of our reporting and analytics dashboard. In fact, you'll notice here on the right-hand side, the screenshot there is actually showing how we can merge coverage from different testing practices, be it unit, functional, or manual tests, and bring that into an overarching view of the code coverage against the application. So our goal here is to enable continuous feedback and quick feedback as part of the process. So unit tests can obviously be executed on the developer's desktop. Static analysis can be executed there as well before you check into source control. Those 2 practices should be gates to your CI pipeline. But then you also want to integrate API testing, functional test, or UI test automation into your CI pipeline, and do it in such a way so that I can execute the critical tests, execute them quick, and get that feedback in the process. And we'll be touching upon those during the demonstration today. So let's talk about the specifics around API testing. Let's kind of reiterate some of the pros and some of the cons. So on the pro side, API testing is actually much more maintainable than a UI test automation. UI test automation suffers from challenges associated with element locators, trying to identify the right elements on the page and creating a locator that can be stable over time. Also, you run into challenges with wait conditions, waiting for UI elements to correctly populate, so you have your element locators available there too. Typically, that's Ajax or AngularJS kind of applications suffer from that. And then thirdly, being able to actually execute those tests takes a lot of time as well. So the UI tests have those challenges when it comes to maintainability. API tests also suffer from maintainability from the point of view of handling change, but it's a lot easier to handle the change because a change in an API doesn't require or doesn't necessarily have to happen for a UI element to change. So UIs are typically a lot more volatile. It also is a great place to communicate between development and QA, and is much quicker to time or reduce the time associated with diagnosing those. However, there are some challenges. Often testers within the team struggle to understand how an API is used so that they can create a meaningful test scenario, often requires specialized skills and tooling to really create comprehensive test coverage. And what often happens is it ends up in this no man's land. The development team may implement an API, they document how it's designed to be used, and they say, great, we're done, we've done some basic validation, it's now the tester's job to test all of the different use cases. Typically speaking, though, the tester is struggling with understanding how those APIs are used together to build out an overall testing scenario. So what happens is the testers spend a lot of time focusing on the UI, and API just gets ignored. So we've actually addressed some of these things, and we'll talk about strategies for that. One thing before we jump into the demonstration, though, would be to talk about what we see from a maturity perspective. So what we typically see is that organizations going through 3 levels of maturity when it comes to their test automation tooling for API testing. The first is to develop your own internal tool or your own internal scripting, typically built on top of curl, for example. It's a command line tool for executing simple payloads, or it might be built on top of something like your Swagger documents. That is typically not very good from a long-term specific use case. So being able to expand scope beyond an individual team, you're also building in maintenance costs, because as your requirements change, the test team start trying to push the boundaries of what they're trying to achieve, you very quickly hit the support cost or the maintenance costs associated with building your own custom framework. So typically, then you move to looking at what's available for open source and free. This is where Postman is very, very popular in the industry. And we kind of view Postman as a great starting point for organizations, especially when you're talking about REST-based communications. However, what often happens is different teams across the organization are selecting different tools, plus those open source tools kind of only get you so far. So remember, we actually did a poll at the beginning where we talked about the different protocols that are in use, and there's a lot of different protocols that are being used. If you've standardized on Postman today, and then somebody says, okay, we've got a microservices architecture where we're going to deploy Kafka, you're going to have to start your whole tool evaluation process all over again. Then your third is the supercar. It's the transformer. It's the thing which has all of the capabilities you need. This is where obviously Parasoft fits in. Highly scalable across your organization, backed up with support from our industry-leading support team. They're able to help you when you hit those critical points in the process when it really matters. Typically, most people find problems with products right before they're supposed to release their own technology, usually in their own crunch time. And that's when you need somebody kind of in your corner to help you with that. And that's where a vendor helps. Obviously, the downside is it does require investment. So if you look at going through this maturity model, the key thing is to build the practice within your organization, validate the business case, and then as it becomes business critical, that's when actually bringing in vendor support really can help you mitigate any risks associated with that. So what we're going to do today is we're going to talk about how we can address some of these challenges. And actually, I'll hand over to Chris here, and he can talk through the things that we're going to touch upon.
Thanks, Mark. Yeah, so we're going to go through a series of examples, how I'm going to be testing an application through a series of different techniques. Essentially, it's going to break down into these 3 categories. The first piece is being able to build API tests as far left as possible. And that is as soon as the API contracts are available, as soon as I have any sort of information about the system. Now, from that, I'm then going to build some dynamic scenarios and then move into a second area, which is all about being able to bridge the gap between the UI testing and the API testing by leveraging a little bit of AI to understand the interactions between the front end and the front end APIs. Then I'm going to talk about a topic that's really important, which is understanding and managing change in your API inventory. And giving you a demonstration of how to create a process that's sustainable. So I'm going to begin inside of the SOA test tool. This is SOA test right here. You'll see that we're built on top of Eclipse, so we have all of the advantages such as source control and things like the workspace. Now, what I'm going to be doing today is I'm going to be testing an application that development is currently working on. And right now, the only piece that's available for it is a Swagger doc. So let me go over here to this and then jump into the admin panel. Excuse me one second. Use the right port. Okay, so the Swagger doc defines all of the different services that are being available in their particular versions, some information about how to interact with them, and a way to test it right here in the UI. In this particular case, it's governed by this service definition. And I do really believe that for API testing service definitions, be there WSDLs, Swaggers, Open API docs, are really critical to the API testing practice because they serve as a foundation for building all of the different API tests that you have. And when it comes to change, it can be a critical enabler for overcoming that process. So what I'm going to do here is I'm going to go ahead and create an API test by consuming that Swagger definition. I'm going to call this Parabank Swagger because that's what I'm using today. And in the tool that you use, you want to make sure that you can cover not only modern definitions such as OpenAPI Swagger, but also legacy definitions. SOAP is still very prevalent in the industry, and so being able to build tests off of that, as well as traffic, which we're going to go into a fair bit. I'm going to go ahead and choose the Swagger def here, pop that guy in, and say finish. Now what this is going to do is it's going to read the definition and create a client for every operation or resource that's available in that Swagger doc. And this is a great starting point for me because at this point I can now create API, let's call them unit tests against the individual operations, validating the response codes that I get back, the data that comes back, the schemas, and then from that, I can then start to build scenarios. Now, I'm going to take a giant leap forward here and talk a little bit about machine learning. At this point, I have a test that's been created from the Swagger doc, but there's some things that I need, such as authentication, different headers, ways that my organization works with this that aren't defined in Swagger definitions. And that's where we can employ something like AI and machine learning. In SOA test, we have a brain. SOA test can become aware of the business rules that are used when testing different APIs. Things like what kind of assertions might I use, what kind of data banks, what types of authentication, what pieces of information. We can get those by building API tests and then training the underlying template every time we do something that's specific to an API. From that point, anytime somebody creates a new test like this one, I can simply use those rules and apply it to my API test. You'll see here that SOA test has said, hey, you need a bunch of stuff for this test. You need some authentication, you need some headers so that you're getting JSON back, so on and so forth. And so it'll go through and update all those tests appropriately. Now I know I have a good foundation for starting. So if we look back at this client, we see that our authentication is all figured out, the different headers that we need. Great. All right, so let's run a test. So here I'm just going to go ahead and make a query. Now, debugging and diagnosing are very important pieces of your API testing solution. In this case, I see that I have a test that's failed. And from that, I have an actionable task that I can jump into that tells me something that says, hey, you don't have an account 0. Well, okay, I guess that makes sense. I don't have an account 0. So what I want to do here is supply some information to it. Now, I can either do this in a fixed way, or I can define a script, maybe auto-generate it based on what's the type in the Swagger, maybe connect it to my test data management engine and parameterize the values via a data source, whatever I want to do. In this case, let's just do a fixed value so that we can get a working test here. Great. Request is being sent to the backend system, to the API with some authentication. I'm getting a response back. Okay, I can now start to set up validations and assertions like you would in your API testing tool. Now, since I've built this from the Swagger definition, I can build a whole series of these different unit tests and use those as seeds for my dynamic scenarios. See, because APIs, they're not used individually like this. Typically, they're used as a part of a scenario. So what I'm going to do is create a quick dynamic scenario. And so I'll just create an empty folder here. And I'm going to jump into my test, and I'm going to pick out some pieces that are important to me. Let's say that the scenario that I want to go through today is getting an account balance, depositing some money into that balance, and then checking it again. So I'll go ahead and paste those calls here, and then I'm going to just double this account. And so the idea is get, deposit, get again. All right, so I'm going to run this guy. All right, so we see that I'm getting the balance, or getting the account with my first API call. And now when it goes to deposit the amount into the account, I see I'm getting an error. And of course, it's similar to what I saw before, because I never configured post. But here's the thing, I don't want to just arbitrarily choose which account to deposit the money into. What I want to do is I want to dynamically pass information between my test steps so that I can create a scenario that's reusable once I attach a data source. To this end, what I'm going to do is I'm going to go through here and use a wizard that allows me to parameterize values between steps. This is critical when you're doing your API testing. Create the most dynamic scenario possible so that the connections between your test steps have a soft reference to each other. You can then drive your inputs at the top, and everything else will just work dynamically as you go through the test. So here what I'm doing is essentially saying the value when I'm depositing the account is the value that I got from the first request. You'll notice that it automatically created a tool here called the data bank, which does what it sounds like, transfers data. Now amount. How much do I want to deposit into this account? Now I could put a fixed value like $100, but I want to be able to test different types of behavior against my application. I think a really good way to start is to maybe generate some random data to put into that deposit. Now, this might not be the way that you would build all of your tests, but in this particular case, what I'm going to do is I'm going to leverage my tooling system to choose the appropriate tool for the job. In this case, SOATest has over 50 plus tools that do things like generating data, looping, grabbing data, putting something into a header, writing into a stateful data object. It just makes it much easier so I don't have to write code for these pieces. All these can be defined as setup or teardown tests and then re-referenced as a part of my library. I'm going to generate some data, so I'm going to use the data generation tool and just create a very generic generation here. Let's say some dollar amount between 1 and 1,000 with 2 decimal places. And I'll call this random deposit. Okay. Save that. I'm going to move this up to the top so that it happens first. And then I can come down into my deposit test. And in a similar way that I connected those tests before, I can connect to that randomly generated variable. Okay, great. Now I have this third test. Now it just so happens that the third test has the same value as the first test, but that's probably not stable. So I'm going to go ahead and use that same variable that I used from the first test. Okay, now I have a dynamic scenario. I can go ahead and execute this. And now I see that I'm depositing different amounts into my balance. Here we have 4,510, and I can run this as many times as I want and validate that the deposits are taking place. Now, of course, no test would be complete without some kind of an assertion or a regression control. And so in this case, I'm going to go ahead and create a very simple one. I'm going to create a value assertion to just ensure that the balance of my account is higher than, let's say, the value that it began with. Okay, we could get more specific about that. And then from this, obviously, it won't be because I'm changing that account balance. And then I can use this to drive my API testing strategy forward. Okay, so from this, I have created an API test from the Swagger definition and then created a scenario from that. We'll see that this becomes really important later when it comes to change to determine these different pieces. Now, when it comes to sharing and collaboration, you're going to need to have a mechanism to share and distribute these types of tests across your organization. For Parasoft, that's the continuous testing platform. The continuous testing platform is a thin client interface that allows developers, testers, and DevOps engineers to come together, plan, coordinate, and execute their API testing initiatives. It hosts a library of API tests, virtual services, and test data, as well as taking an environment-based approach to testing, which we'll go to in just a second. So here, what I'm going to do is I'm just going to pull in the latest API tests that have been created across the organization. Now, since I'm the only person working on this right now, it's only going to find my one test. But nonetheless, we'll pull this piece in here, run this in the background, and then I should be able to drill right down into this area. And then there's my test. Now, the great part about this is that whether I have the desktop client or whether I have the browser-based client, we can still share and collaborate on the same test case. And if somebody wants to borrow some of the information that I've supplied into my test case, well, go ahead. You can copy this down to your local environment, execute it directly here, or connect it to an environment. But I want to talk about the second piece here, which is bridging the gap between the UI and the API. You see, up to this point, everything that we've been doing is a very by design approach to API testing. I'm testing that the APIs are working the way that they were defined in the Swagger. However, that doesn't necessarily connect to how the APIs are actually being used by the application. See, the application will be connected once the UI is available to these APIs, and they'll be called in ways that has been determined by quite often the development team. And so what I want to be able to do is, in tandem with my UI testing, test my application and simultaneously pull out those API calls so that I can have a doubled strategy to my testing. Yes, I have UI testing at the front, but if I see that my API tests are failed, maybe I need to look at those before I look in deeper into the UI tests. To simplify this, Parasoft has a built-in recorder that allows us to record APIs as they're being used from the website. So I'm going to go ahead and start a recording here, and then just use this application. See the same credentials as my application. Okay, I have some accounts. I'll dive into this one, and then maybe dive a little bit deeper. I could do some transaction information, but let's leave it there. I'll go ahead and log out of the application, and now I can stop my recording. So now what's going to happen is that I can create an API test. We'll call this Parabank Accounts scenario. I can associate a requirement with it so that I have traceability, and then simply create the test asset. Now what's going to happen under the hood, well, it happened rather quickly there, was that a combination of the previously learned rules and AI are going to parse the traffic that was generated during the execution with the application and build an API test for me. And so what I have here is a true API test. I can see I log in, get my account, look a little deeper into the account details, and look into the transactions details. What's great about this is that things like assertions and data banks are auto-generated through the AI by analyzing patterns and relationships in the API calls. And it just takes a lot of the grunt work out of this process and makes it much easier for me to build a foundational test, make some changes to it, execute that as part of my CI process without having to spend a ton of time inventing the wheel every time there's a new user interface. Now, all of these different test cases can be connected to all the other types of testing that I'm doing, be it maybe a mainframe MQ via copybook, or maybe some of my microservices using Kafka into this test library and then associated with my environment. So in the continuous testing platform, we take an environment-based approach to testing, which means that a test environment has an application that you want to test. That application will have different interfaces on the front end, services that you're interacting with, and then back-end dependencies. You can visually diagram those environments and then associate test cases, test data, different environment configurations, and ultimately virtual services to those. And then from that, you can provision just the right environment for your usage. So what I'm going to go through here is a typical example where I have those tests that I just created, and I'm going to just connect to my default deployment, which is mostly a live environment, and then run a series of my API tests. I'll go ahead and hit this provision button, which is going to make all sorts of things happen. Why don't we peel back the cover a little bit and we can look back at SOA tests, because API tests are a little boring to look at, we'll notice that it's going through a whole bunch of API tests, and then it's going to launch a UI test. And essentially, this is me saying, new application is available in this environment. I'd like to test it. Okay. Now, here's the interesting part. I have an error on my screen. That error is coming from my UI test. It's not giving me a whole lot of information, so it's not clear to me what's happened with this new code deployment. But what I can do is I can drill back down into my environment and let my API tests tell me what happened. So here I see that a series of API tests were fired off. Okay? I also see some back-end systems. We'll get to those in a second. Let's go ahead and take a look at the results of that. Okay, so here I see a report indicating all the different API tests that were fired off, 43 total tests, 40 of which were successful. I can start going down through here and identifying, well, something happened with the request loan service. And I also see down here, there's a part of the API unit level tests. Something's wrong with request. Also with my Selenium-based UI test, I can also see something just isn't quite right with that system. Now from this, I can go through and probably identify that there's something wrong with request loan. Let's look at the API details, but I want to point out something a little more important, and that is API coverage. So one of the ways that you can validate that you are being efficient with your API testing is ensuring that you're adequately covering all of the APIs or resources that are available in your system. So in this case, what my report is doing is it's aggregating all of the resources that are available for that service definition. It's indicated to me, hey, you've got a problem for sure with the request loan operation or resource. But I got to tell you, a bigger problem that I have is I'm definitely limiting the scope that I have been testing this API. There's all sorts of functions around selling positions and parameters that I'm just not testing. And that actually presents a bigger risk to me than this particular piece. But nonetheless, I want a successful test. So what I'm going to do is dive back here into my engine, or to the diagram, and say, yeah, those tests failed. What's this guy down here? Oh, the test failed because one of my dependent endpoints, a back-end service, is offline. Now we know this because we are proxying the communication between this service and the back-end system. We've done this because we ultimately wanted to build a virtual service from that. Now, in the case of building a virtual service, it's very similar to what you saw through the API testing engine from the UI. We analyze the traffic, we look for patterns and relationships, and we build a simulated service that has just that data. We can then load those into this environment so that we can choose the correct one at the right time. So for my use case, I want to execute some positive tests. So I'm going to choose a positive virtual service, load in the data that I need, and I'll either press this button or execute this in a headless way as a part of my CI process, which we'll dig into in just a second. I'm going to go ahead and provision this. Again, we can look in the background, see some of those API tests fire off. And then, of course, my UI test is going to come, and I have greater confidence at this point that this test is going to be successful because I stubbed out that back-end system with a virtual service. And through this, I can validate two specific pieces. One, has the code that's just dropped is it sound? And I can do that at a unit level API test validation. Then, by doing scenario level testing, I can validate that is my UI test going to be successful? If those UI tests fail as a part of a scenario, chances are my UI tests are going to fail. But since I was able to identify that the issue was environmental and not based on a code change, by swapping in a virtual service, I've stabilized the test environment and validated the build. Now, all of this information can be brought up into a CI platform. I'm going to demonstrate Jenkins today, but the ideas are similar no matter what system you're using. So we have this idea of our builds. And every time that we make a build, we want to continuously validate those APIs. And we can do that by creating that environment bundle of API tests to say, whenever this code gets checked in, let's deploy this test environment and whatever data, and then execute just the right set of API tests to validate that. Pass or fail, we'll get that information back here into Jenkins. And if we have a failure, we can trace that information right back to the environment that was currently being deployed at execution time. And this makes it much easier to debug that information. Okay, so that's the second piece of the demonstration, where we're not only bridging the gap between the UI and the API, but also showing how to build this into a continuous delivery strategy. I want to spend time talking about this critical piece, maintenance and change. You see, this all falls apart if we create an API testing strategy that just breaks every time we have API change. So you need to put in place an API testing strategy that employs change management workflows. For Parasoft, that comes in the form of monitoring or scanning the service definitions. So a test can proactively scan these service definitions, and when a change is identified, we can create a change template. And a change template maps different versions of the API definitions to each other, and thus maps different versions of test cases to each other. From this, we can identify small changes, like an operation was changed its name, as well as identifying something a little more aggressive, such as elements are changing location. Maybe there's elements that have been added or removed. From this, we can make whatever changes we want to make. In this case, I'm just going to do something really simple. Disconnect price from genre, connect price to amount, because that's actually what changed. Say, hey, this parent is okay. And then maybe define a default value for a string like this. We can then go into our test case explorer, go to those tests that are affected, and immediately bulk refactor those test cases using the change template. And this is great because one person can create the change template and multiple people can use that. So here I have my old version, and now I have a test case that's updated to the latest version. But any assertions or data banks or data sources that I've created stay in place. I just overcome the change. And through that, you can build a very scalable API testing strategy. So real quick, what did I do? There's many challenges that are associated with testing your application, and they come in the form of having multiple interfaces that you test. There are many open source solutions to do this, and I encourage you to take a look at those, because we can get ourselves into a mode where we're starting to separate these different types of testing and moving down the testing pyramid, as Mark indicated. But there comes a time, as we saw in the maturity model, that we need to look towards something that will have more optimized workflows for the types of things that we're looking for. Test generation, change management, integration with CI processes. Parasoft SOA Test has strived to simplify this process, as well as any of those test cases that you create can be strung together with, say, your Appium or your Selenium testing initiatives to create an omni-channel test, as well as being leveraged for performance and security tests for earlier stage or shift left performance testing. We also know that once we create all this great test automation at the front end, the challenge really shifts into the back end system. And it comes in the form of fee-based APIs that we want to test. Maybe we want to do some performance testing and the services aren't quite ready or don't have the behavior that we want, or it's just too expensive to run in the performance environment. To that end, we can create virtual services by recording the traffic, creating a virtual representation, and then providing them with all of the data that they need to behave. We can link these two pieces together through test data management, leveraging data from our API tests and our virtual services and vice versa. And then as I demonstrated, we can wrap this all up into an environment or an environment template. That environment template can then be deployed on demand as a part of a CI process to a local tester to validate in isolation, or wrapped up as a part of your CI process. Whereas a function of code check-in, we can spin off multiple versions of the environments, either on-prem or leveraging containerized technology via AWS and Azure to get just the right test environment at just the right time so we can execute those API tests the moment we need to. All of this comes down to giving us better results, more realistic results targeted at this crucial layer of our application, the API. All right, but Mark, why don't we talk about how some real customers are taking advantage of things like service virtualization?
Great. So, and actually, we got a whole bunch of great questions that were coming in during Chris's demonstration there. Unfortunately, probably won't get to all of them, so we will respond to all of them though, and we'll follow up after the session. But let's take a few moments here to try talking about a couple of case studies. Please do continue to put questions in there, and Chris will answer them as I'm talking through here. So as we talked about, service virtualization has a few what I view as key use cases that can help unblock organizations and really enable continuous testing. The first use case, which I think is very, very powerful, and I would probably say that 80% of our clients that are investigating service virtualization are investigating it for this use case, which is around how they can shift left performance testing. As we discussed, your applications are complex now, right? It's not just one component that you're testing how that component is interacting with other systems. Microservices makes that even more complex with a lot of dynamic infrastructure that's maybe not within your control. So here's where service virtualization can help. So what I can do is in a system where, for example, I'm trying to push, let's say, 1,000 transactions per second through my component, the thing that I have control over, I may find that I am constrained by my back-end dependencies. Maybe they can only handle 10% of the throughput that I actually want to put through the overall system. With service virtualization, what I can do is I can monitor the behavior and understand how my application under test is communicating with that back-end system, and then create a virtual asset that simulates that behavior. We can then control how that virtual asset responds, not only from the point of view of its functional characteristics or the data that it's using, but also its performance characteristics as well. So now this gives me the ability to be able to really push the load through the system that I'm trying to test and I'm trying to validate, and do that in a way that's scalable and also reduces the dependencies on that back-end system, which may not be available during my early stage performance testing, or it might not be scalable to the size that I need it. As I say, this comes up with a lot of clients. This particular example is a major utility company, but I would certainly say that telecommunications and financial services are two key industry areas that leverage this very often. Now, also another use case, and we see this with organizations that are trying to aggressively shift to an API-centric business model, where different teams are broken out with siloed responsibilities, and then each of those teams are kind of trying to coordinate together. This particular scenario often I will refer to as kind of an agile bottleneck. Basically what happens is at a particular point within the development process, I am waiting on different teams. Maybe the iterations don't line up, or maybe the functionality, the capabilities that I depend upon from those other teams is not ready yet. In this particular scenario, one of our clients in the entertainment industry would use virtual assets to be able to simulate or prototype that functionality that they're going to be developing, which does two things. Firstly, it does unblock the teams that have those dependencies, but it makes the teams that are building those capabilities kind of make more conscious decisions about what the contract should look like between the two applications, plus also the effort of building that kind of POC or prototype really kind of flushes out a lot of the use cases and usually helps them accelerate their implementation process. Now, this particular client also, when service virtualization was kind of out of the play, or actually as they would go as part of an ongoing iterative process, embedding in SOATest to both validate the functionality that you're developing that's dependent upon those virtual assets, but also using SOATest to validate the behavior of the virtual asset itself, and then switch out the virtual asset for the real instance and make sure that the real instance is actually working as you would expect the prototype to have worked. So using both SOATest and Virtualize together really gave the ability to kind of enable true continuous testing within this team, and actually help them accelerate their delivery against their project schedules. My third and final use case is specifically related to a particular client that we have within the financial space. This particular client had a back-end transaction processing system provided by Fidelity. It was actually a third-party system. And the challenge is because this system was expensive, it had an annual cost associated with just the infrastructure that, from the third party, but also in the human cost of managing that infrastructure from the point of view of our client. So what they would do is they would, in essence, time box access to that server. And what would happen is if you were not ready when your time slot came along, didn't matter, you didn't get your time slot back. If you failed at the beginning of your time slot, didn't matter, you didn't get the time back. So what they found is that they were being teams were frantically scrambling to try and get everything ready before their time slot came along. They'd then jump into their time slot and they'd be doing lots of defect resolution rather than regression validation. So that was obviously making the team not very successful and ineffective. So what this particular client did instead was monitored the behavior with that backend system for each of the application teams, created virtual assets that would model the behavior that team was expecting from the backend transaction processing system. This gave the teams the opportunity to shift left their integration testing and do it earlier in their pipeline, in essence, shaking out all of the defects before they got into the integrated environment, and then leveraging Environment Manager, the component of CTP that Chris was showing us, able to reconfigure the application so that dynamically we can just take our tests and run them in my integration environment. It doesn't remove the need of the integration environment. In fact, actually, that was one of the questions that we got during Chris's demonstration. You still want to test in an integration environment. What you're doing is you're optimizing your use of that environment and, in essence, optimizing your investment. So you're not investing in numerous large test infrastructures. You're, in essence, enabling the individual teams to get the job done themselves. So kind of wrapping up today, and I think it looks like we're on top of the questions as well, so that's great. When we look at how to enable continuous testing, there's really three pieces to the problem. First is you want to have data-driven API tests that can seamlessly plug into your CI infrastructure. The test, everything that Chris was showing, can be fully executed from the command line. We have native plugins for Jenkins, Bamboo, TeamCity, and VSTS. And by plugging that into your CI pipeline, you're able to get immediate visibility and immediate feedback. The thin client ecosystem of CTP gives you a great collaboration environment where teams can get in, reuse somebody else's functionality or example test cases. Also, where it gives somebody the ability to just jump in, create a simple test artifact that then can be taken and expanded by others within the team, maybe using the full power of the desktop. And then lastly, and not to be forgotten, is service virtualization. For me, this is the real key that unlocks continuous testing. You make sure that your tests are fully automated. You make sure your tests are created in a reusable manner, but then you'll run into the constraints of the test environment. This is where service virtualization can unblock you, shift left the execution, get much quicker feedback, so that when you get into your integration environment, you know that it's all going to work. Okay, so we've done this for a number of different clients. We've been solving real problems within the organizations, helping organizations achieve higher levels of test coverage. Reducing tester fatigue is a very key element that Chris with the Smart API Test Generator, this is one of the things that really helps you supercharge your testing process, and getting earlier access to the test environments with service virtualization. Now we're getting close towards the end here, so just a couple of calls to action. If you'd like to learn more about API testing in general, we have a great e-guide around choosing the right API testing solution. And we also have a companion one for service virtualization as well. Both of these talk about the key capabilities that you need, but they'll also talk about the maturity model and what you need to kind of help you go through that process. So with that being said, I see a couple more questions come in. I also see Chris frantically typing behind me. Is there any that we want to highlight there?
Just a general, I see, first off, there's excellent number of questions here. I've been trying to kind of answer them as we've been going through, but in general, there's a lot of questions around performance testing, specifically how it relates to API testing. And just a comment that I would make is that to really enable this shift left performance testing, you want to leverage the API testing practice that you're already going to be doing. And by creating those API tests as soon as the application becomes available, or excuse me, the APIs become available, you're making the foundation for those performance tests. Many people think I'm going to run my performance tests in a big performance environment with big performance machines, but the reality is that by leveraging your unit level or API level functional tests, you can do a performance test maybe on an individual component, and then run that continuously over time, aggregating that data to see if there's any performance degradation, especially when you're doing things like microservices and you're adding different functionality to them. Finding that early will help you instead of having to do it at the very end by rolling back the whole environment.
Yeah, and actually identifying those performance degradations as quickly as possible is critical to ensure that you're going to be successful with your agile DevOps initiatives. The reason why I say that is when you're going through these iterative sprints, the intention is that you don't go through a long QA validation certification cycle. Mm-hmm. It should be relatively quick. So if you're leaving performance testing until that last part of the process and you uncover your performance test or your performance issues right at the end, you got no time to fix it. Plus, you actually don't know when you introduced it. So by running load testing continuously and doing it at the API level means you use the most efficient way possible. You don't have to worry about browsers. You don't have to worry about scaling of infrastructure. I think that's very key. Now, we did get a couple of questions around kind of reaching out. So there are a couple of links here which will take you to the particular web pages. We do have an email address, info@parasoft.com. You can email that one. Plus, you can also contact us via the Try Parasoft or Try Soatest link on the website. Somebody was asking about how to get access to a trial. That's the best workflow for doing that. Okay, I think we're bang on time. We didn't get to all of the questions. There were some which we'll follow up on afterwards. Yep. Please feel free to reach out to info@parasoft.com. I just put the email address there at the top of the slide. Thank you very much for your time today. Any closing questions or comments, Chris?
Happy testing.
Happy testing. Thanks very much. Have a great day.